Dr. Buzz Powell, and he will be speaking on MNRoad and NCAT testing updates.
Well, I appreciate the opportunity to visit with y'all this evening and provide you with an update on the research partnership between Minnesota Road Research Project and the National Center for Asphalt Technology. I love coming and meeting with groups, the state agency partnership groups, because as he said in my introduction, I started my career with Alabama DOT, and actually, little known fact, I started out as a computer programmer, and I came in and helped Alabama to build the original pavement management system in the mid-'80s, and I got more interested in the engineering stuff than the programming stuff, and changed over and started over in college, and kind of the rest is history for me. So the fun thing about that is I share y'all's passion, the passion that Nate mentioned. I share it for pavement management and for pavement preservation and for the decision-making process. That's where I started my career, and I have a very rewarding job at NCAT now because we're working to support all the state agencies that are funding partners in our research. So NCAT, National Center for Asphalt Technology, we're a research center that was formed in 1986 as a partnership between Napa's Research and Education Foundation and Auburn University. So we exist to do research to improve the performance and the value of asphalt pavements. And in the late 90s, we started construction on our pavement test track, started the first round of research in 2000, and then every 3 years since then, we rebuild the track and use a fleet of heavy triple trailer trains to compress the design lifetime of traffic into these 3-year cycles. And through this research cooperative, we sell test sections to state DOTs, to FHWA, and to private sector clients. And we help state DOTs to innovate. Tom Harmon, talked a lot about innovation in his presentation. Well, we're very proud to help state DOTs to innovate, to bring about positive change in their practices. Well, beginning in 2012, in response to the expressed needs of our state DOT clients, we started doing off-track research in pavement preservation, low traffic preservation in 2012, high traffic in 2015. Minnesota Road Research Project, where we're a nonprofit research center inside of the Auburn University family there in Alabama. MNRoad is actually part of the Minnesota DOT. They're part of the research division in Minnesota DOT. And we became very good friends with our partners now at MNRoad in the early 2000s through our work on TRB committees together in accelerated pavement testing. Well, and I'd say probably the mid-2000s, Minnesota, at the Minnesota Road Research Project, they wanted to evolve their experiment from being a 100% Minnesota-funded operation into a multi-state research cooperative like we have at NCAT. So we kind of helped them to make that transition with what they call their second research cycle there at MNRoad. Well, when we got into doing pavement preservation research in 2012, and we had our low traffic work that we did, well, we kind of working with the help of FP2 with the preservation industry, we got this grand vision for what could become a nationwide impact experiment in low traffic and high traffic and hot climate and cold climate research. And so we engaged in a partnership with MNRoad, an official partnership beginning with our 2015 track, and we built test sections in Minnesota to match the test sections that we'd built down at NCAT on our track and off our track. So that's where the partnership came from. And what I want to do this evening is provide you with not just an update on the research partnership, but really focus on some of our findings from the partnership, because we've been doing this now, collecting data, preservation benefit data since 2012, and we've got some really good information to share with all the state agencies at this point in time. The first thing we always like to do is acknowledge the states that support the research cooperative, the National Transportation Pool Fund. We grew from 8 states when we first started the track to now at least 20 states, probably going to be 21 states here over within the next couple of weeks, because another state is joining. We'll be adding a state to this graphic here very soon, and that's because of the Minnesota partnership. So you'll see states on there like Wisconsin and Minnesota, the northern states that have more of a focus on the really aggressive thermal cracking performance issues that they have in the extreme north compared to what we have in the Gulf Southeast. So the partnership has been good for NCAT. It's been good for Minnesota because it's done exactly what we hoped it would do. It really increased the impact of both of our research programs at Minnesota and at NCAT. Now we still have things that we do outside of the partnership. They actually are two National Transportation Pool funds that fund the cooperative research that we have between the two facilities. But NCAT still has work that is specific to the NCAT pavement test track that's outside of that partnership. And then Minnesota has what they call the National Road Research Alliance, that other states can come in and they fund other research on their facility up there. But we do have a great working partnership with them, and I'm going to share with you some of the findings from that today. I've got one background slide I really like, starting out kind of theoretically talking about the life cycle curve for pavements and what is preservation, rehabilitation, and reconstruction. And when you overlay onto this thing an ASTM style PCI grading scale, and then you look at how some of the states go in, some of the agencies go in, counties and cities, and have historically done kind of the worst first approach to the work that's needed to be done on a roadway based on what the severity level of the roadway is. Of course, in pavement preservation, what we want to do is keep things up on the high end of the scale. I really like this graphic, and I'm going to actually update this. I was in New Mexico doing some training a couple of weeks ago with Jeff Mann and the guys from the New Mexico DOT, and they've actually put on their y-axis on a graph like this dollar values. And so on their scale that they have for life cycle pavement performance, they go from 0 at the top of the y-axis where you first build a brand new pavement, and then the bottom of the y-axis is just under $1 million a lane mile. So they've actually gone in and gone through their maintenance and construction databases, connected that to pavement management, and they're able to go in and put dollar values on the different options, and it kind of helps them to focus their resources on staying up in the high part of that curve, because what we really want to do is select those options that give us the best possible life cycle cost and investment. The challenge that most state agencies have, maybe not the majority of agencies in this room, is they get feedback from our pavement management system, and pavement management tells them, well, this treatment can last anywhere between 3 years and 10 years. How do they know what number to use when they're doing a cost analysis to try to decide what treatment to use on a particular roadway? What most agencies do is they just kind of pick an average value. They say, okay, well, 3 to 10, so we'll pick a number right in the middle of that for this treatment, and then we'll pull our cost per mile or our cost per square yard, and then that's what we'll use to do our life cycle cost comparison, so we can pick an alternative. And we know that's not a good way to do it. That kind of is a political out for a lot of agencies, because they're getting pressure from a lot of different directions to explicitly choose specific treatments and specific alternatives. Well, and that kind of is the background for why this experiment came to be, because what we want to do at NCAT and through the NCAT MNRoad partnership is provide that objective life cycle cost information that actually means something based on the pretreatment condition of the roadway that states can use to make their selection decisions. So our number one objective, what we want to do is quantify the benefits of preservation. And to do that, you got to have good materials, you got to have good designs, and you have to have good placement quality. Because if you don't have all three of those things, you're going to confound the outcome of the experiment, and you're going to see some good performance and some bad performance that is not a reflection of the pretreatment condition of the roadway. So what we wanted to do was start out satisfying these three things, so that when we saw different levels of performance, we knew that we could relate it back to different levels of pretreatment condition. So our designs then were verified using actual on-site materials. So we did our designs using quarry materials. When we had material delivered to our job sites, we did on-site sampling, sent that material out, and had it verified so that we knew we had good materials and we knew that we had good designs. All the rates that we shot for all the different treatments, they were all calibrated before we shot and then verified at the time that we shot. So we went to great lengths to make sure construction quality was really good. Kind of relating this back to my experience with a state agency, with Alabama DOT, typical practice, I think probably still in Alabama DOT, certainly true with the counties and many of the cities, is there's a table that says, for this type of treatment, here's the rate range you can shoot, and then it's up to project personnel to go out there and decide what rates actually to shoot. So, we had the benefit of knowing we had good materials and have good rate designs, and I know lots of times in the state agencies we don't have that, but that's something that we've got to change. We've got to improve that so we can make sure we can have the expectation of having a really good performance outcome. So with all these things in place, low traffic, high traffic in the south and low traffic, high traffic in the north, the focus of the analysis then is MAP 21 performance criteria. So, we're focusing on cracking, rutting, and roughness because these are all flexible pavements that are in this partnership. But we're also tracking a lot of what I would refer to as outside the scope of MAP 21 performance measures, like friction, and the cracking that we're measuring is a reflection of the MAP 21 approach to cracking, but we're differentiating between different types of crack, inside and outside the wheel path and so forth. So what we're doing is we're quantifying the benefits and relating them all back to different levels of pretreatment condition to attach a number to when a good road lasts a long time with a treatment on it compared to a bad road with the same treatment on it. How does that affect your expectation of life cycle performance? And then of course the end game for all this is implementation with the agency, support for deployment. And that now is our big focus in the current research cycle in the NCAT MNRoad partnership, is to support deployment of the things that we're learning. So if you look at the options that the preservation treatments and the treatment combinations that we've included in the study, we've got emulsion focused treatments and we got plant mix focused treatments. On the emulsion side, fog seals with and without rejuvenators, chip seals with and without rejuvenators as scrub seals, and with and without fibers. Microsurface, plain microsurface, highly polymer modified, with and without fibers, and then single and double layer microsurface treatments. And then also microsurface as a quote cape seal on chips, Pavement chips, and on scrubs. So I put air quotes around cape seals because, as was pointed out to me, internationally the true cape seal is a slurry seal on top of a standard chip seal, and we don't have any slurry seals. All of our slurry seals are polymer modified, so they're all microsurfaces in our standalone micros and in our cape seal treatments that we have. On the plant mix side, the focus very much is small, dense graded plant mix asphalt. So when I say small, that's a screening and sand sized mix, and all the screening and sand mixes that we do research with relate back to a very successful mix that was supposed to have been a low volume road experiment on a 2003 test track. It was designed for 500,000 easels, and it's now been down for over 50 million easels and still looks great to this day. So that was what I was taught at Alabama DOT, that those mixes, they had their place on low volume roads, but you just couldn't put them under heavy traffic, and that mix taught me that was not true. So the dense graded thin lays that we do work with are kind of all cousins that relate back to that mix in 2003 that was just stone screenings and sand, natural sand. So we've got virgin versions of it, 50% wrap, 5% shingles, and then finally the mix design that we settled on in a balanced mix design approach, so that we had both rutting performance and cracking performance and a good reasonable cost approach to the mix. It's 11% fine fractionated wrap and 3% shingles. And now we've done that same mix in the southern test sections, and we've also done the northern variant of that mix up in Minnesota. We've got the same mix on 100% wrap cold recycle mix, and that's central plant and in place with both foam and emulsion. We've got the thin lay version of what Tennessee calls HMA cape seals, just thin lays on top of chips and scrubs. And then finally, we also included some OGFC surfaces with some different tack materials, because especially the southeastern states, they love the spray reduction and the safety enhancement of the OGFCs, but they've had some performance issues that we're studying different tack options to alleviate. So these are the treatments and the treatment combinations that are included in the experiment. And again, we've got low traffic, high traffic, hot climate, and cold climate installations. So I'm going to go through those really quickly before I share some kind of hot off the press data with you. This is our original low traffic road that we did back in the summer of 2012. It's a dead end access road to a quarry and an asphalt plant. So we got empty trucks running in and loaded trucks running out. Both the lanes are treated with the same treatments and treatment combinations. And so it gives us a really diverse surface area of good condition, fair condition, and poor condition. So if you look at the easels that have been applied since we applied these treatments back this summer, will be 6 years ago, we've got 70,000 easels on the inbound lane. That number doesn't change much if you've heard me talk a lot about this. The outbound lane numbers, they change a lot though. 880,000 easels in the outbound lane over 6 years. So it's a very low traffic level on this road, but those are fully legally loaded trucks for the most part in that outbound lane. The high traffic version in the southern half of the experiment is US 280, about 5 miles from the NCAT pavement test track. Alabama DOT gave us the westbound truck lane for about 4.5 miles, and we've done the same treatments out there that we did on Lee Road 159, the low traffic installation. Since we applied these treatments, we've got 5.6 million vehicles in that westbound truck lane, and that equates to 1.6 million easels, and we've got traffic monitoring hardware in the middle of that 4.5 miles that we use to keep track of those numbers. And these sections have all performed really well. This is a very high traffic US route, and this is one of those places where Alabama DOT would have never considered many of the options that we put out there if they were just looking at what kind of maintenance activity they wanted to do to this road. They let us do this because they're one of the funding partners in this experiment. And that's good for the southern half, more or less, of the United States, but for cold climate, you know, where you go through the deep freeze up in the extreme northern United States, you know, we always got feedback from states, hey, this is great. We've never seen this variety of treatments and treatment combinations in one place, but it doesn't really, your numbers are not going to relate to us because we're in a climate that's so different from y'all. So when we engaged in this partnership with MNRoad, we did that in part to address those concerns. This is an aerial shot of the Minnesota Road Research Project, and we've actually got mixed performance research that we're doing there, some of the same stuff we're doing on the test track, and we've got some preservation treatments that we've put there on the low volume loop. But we did the same thing in Minnesota that we've done at NCAT. We've got a low traffic roadway, County Road 8, and then a US route, US 169. Those are located actually about 45 minutes to an hour north of the MNRoad test facility. US 169 runs north and south, and then County State 8 Highway 8 runs east and west. If you look at the traffic levels for these roads, I brag a lot about our brothers and sisters at MNRoad. They picked these roads, and they're the perfect companions to the test roads that we have down south, to the county road and the US route we have down south. Virtually identical traffic levels, and the big feature that they have up there that we didn't have is really aggressive thermal cracking on the low traffic roadway and the high traffic roadway. Now the way we collect data on these test sections is we divide the wheel pass, and then we break them up into a whole series of subsections, and we map cracking, we measure roughness, we measure rutting, we measure all of our different performance parameters discretely within those subsections. So we got a lot of pavement surface area in good condition, a lot of surface area in fair condition, and a lot of surface area in poor condition. The neat thing about the experiment is we're seeing the same trends really in all of the data. And one of the things that I talk about a lot is the benefit of crack sealing. We've really seen the performance benefit of crack sealing as a standalone treatment, and then as you see in this picture, as a pretreatment for when you're going to put microsurface down. Now, you know, those of us who know something about preservation, there's a lot of us in this room, you think, Well, you know, it's not a good idea to put microsurface down when you've got cracks. That's kind of a violation of one of the principles of the use of microsurface. Well, keep in mind that when we put these treatments and these treatment combinations down, we did it knowing that in the part of the section where we did have a lot of cracking, we expected to see the reflection of cracking as a significant distress in those areas. So we've got a lot of good performance area in these two test sections in particular, a lot of fair and a lot of poor, and this is one of the areas where we've got some poor pretreatment condition, and it's in the more heavily trafficked outbound lane in that outside wheel path. But you can see in that picture the benefit of the crack sealing. It really prevented a lot of the cracking to reflect back up into the microsurface, and we've seen the same thing. Low traffic and high traffic down south, and then low traffic and high traffic up north. We're monitoring roughness and we're monitoring rutting, but we're just not seeing a lot of change in roughness and rutting. You know, what we've seen on the track is a pavement pretty much has to be in the process of failing for roughness to be significantly increasing. So we see a lot of flatness in the roughness data and in the rutting data. So what I show a lot when I do presentations is the cracking data. And what I'm going to share with you is cracking data that really is kind of hot off the presses. We try to vet the data in 6-month pieces. So I'm going to show you data through 5.5 years of performance off of Lee Road 159. And it's the same, this methodology that I'm going to show you is the same methodology that we're applying to US 280 and then 169 and 8 up north. So this is a plot that shows again, through the lens of map 21, where the green data, the area of the pavement where the treatment was applied was in map 21 good before the treatment was applied. Yellow was in fair condition and red was in poor condition. The solid line is the cracking that we're mapping post-treatment, and the dashed line is based on the cracking that was there beforehand and based on our control sections, where would the cracking be if we hadn't done anything to the test section. So this particular data is for a single layer chip seal with crack sealing, and what it's showing you is, for example, for the pavement surface area that was in fair condition, you get about 5 years of life extending benefit out of this treatment, the shift in the x-axis, and at year 5 you get 20% improvement in the amount of cracked area at year 5. So there's a lot of the data that we have where we haven't defined the life extending benefit yet, because you got to cross the origin point on the y-axis. But at any point in time, you can look at the gap between the solid line and the dashed line, and you can calculate the condition improving benefit. And this is important data, as y'all know, with the map 21 criteria. You know, you've got to be able to do projections from your pavement management system based on action, different types of actions versus no action, assess the condition of the network so that you can maintain spending authority and maintain the percentage of your network in the right condition. So this is the methodology that we're delivering to the funding partners in the experiment for all the different treatments that we have. So that's the single layer chip seal with crack sealing. This is single layer microsurfacing. So think about how these curves are shifting. And again, the solid line, that's performance after the treatment has been applied. So with a single layer microsurface without crack sealing, as you would expect, you see a pretty significant drop because the cracking is going to reflect there. Interesting thing is when you do a double layer microsurfacing, just an extra pull of microsurface completely changes performance. And many of y'all here have been to Lee Road 159 and have walked the road, and you've seen this for yourself. There's a significant improvement when you're using micro, when you make multiple passes, when you make 2 passes. This is data from the virgin thin lay test section. This is with neat asphalt. Again, excellent performance, but the part of the section that was in pre-treatment poor condition, you're beginning to see a drop there when you get out past year 4, but good performance. This is what happens when you put 5% shingles in that thin lay. And this is a 3/4 inch thin lay where all we did was broom it, tack it, and pave it. We didn't do any repairs to any of these sections except for the crack sealing that is specified within specific test sections. And we developed this test plan, by the way, with the support and cooperation from FP2, who's also a funding partner in the experiment. We got kind of a task group together, mapped all of our pretreatment distresses, laid out everything that we wanted to put there, and then we worked that through the states that were funding the experiment, tweaked it a little bit, and then we installed everything with their assistance and support. So you put 5% shingles in it again. That's the virgin thin lay with neat asphalt. Put 5% shingles in it. You hit about the 4.5-year point, and you start to significantly turn a corner when you had a lot of cracking, pretreatment, poor condition, again, primarily in the outbound lane and that outside wheel path. So to summarize all that, we have seen the value of good materials, good designs, good construction, and good inspection. You know, we've had good performance from all the treatments and all the treatment combinations. What we're doing now is quantifying the life extending and the condition improving benefits, the X shift and the Y shift in those performance curves. And that's the data that you need at the state agency instead of just using the average value for your treatment comparisons. You look at your pretreatment condition of your roadway from Pavement Management, and then you can pick the curves that are the most appropriate based on your pretreatment condition, and then you can do your comparison. We've also been able to measure the reduction in subgrade moisture contents. We're still doing that, Jim. We just got a set of data back in. It was emailed to me this week that my team measured, and so we've been able to show when you've got a good treatment down and you keep the surface sealed, what happens to the moisture content in the base and the subgrade. And we've been collecting those data again for 6 years on Lee Road 159. We have seen similar trends north to south, low traffic to high traffic. The good news is, and this, Jim and Rod, this might be news to y'all and to the states here that are part of the funding partnership, but we're now planning with our MNRoad partners to do cold recycle and FDR next summer, not this summer because it's too late to get it in the bid cycle because of the short paving season they have in Minnesota. But we do fully expect to get cold recycle and FDR in the cold climate, which we have not previously had. So we're really excited about that, and that should go down in next year's paving season up in Minnesota. We anticipate collecting data from all these test sections for a long time, and so we just did a 3-year extension on the pool fund. So we're referring to this as a 2018 research cycle. There actually are 2 separate pool funds. The preservation research is in a pool fund now that's being hosted by Minnesota, and then we've got the other stuff that is under the pool fund, National Transportation Pool Fund for the NCAT Pavement Test Track. Part of the emphasis in this cycle is going to be support for deployment. So I'm really excited. My job is evolving just a little bit, and I'm excited about being able to work more. One of my favorite things about what I do is working with the states to actually bring about the innovation, the things that we learn, implement the things that we learn on the track and off the track, and I'm going to be doing more of that in this research cycle. So hopefully I'll be working directly with some of the people that are in this room. We've got 20 different states that are now in the group. We think it's going to be at least 21, and we've got quotes out that could bump that number up to about half of the states in the country. So that'll really be a milestone for us when we get half of the states in the continental United States. We hosted a conference back in March, and the reason why I'm mentioning it, if you want to dig a little deeper into the data that I've presented today, you can go to ncat.us/pavetrack, and you should see an agenda from the track conference. So if there are any of the individual presentations that you want to get a little deeper into, you can click on those on the agenda that's shown on that page, and the presentations will download so you can get a little bit more information. And then if you can't find what you're looking for on the web page, email me and I'll be happy to follow up with you directly. I've tried really hard to finish on time and to not interfere with the casual fellowship that I know everybody's looking forward to. Those of you who know me know that's really hard for me because I'm very excited about the research that I do for y'all. And Jim Moulthrop wanted me to let everyone know that we have some flyers that are out at the FP2 table that provide some more information in addition to the presentation that I've made today. Thank you all very much, and I'll be around tonight.
The preceding was produced by the National Center for Pavement Preservation. More information can be found on the web at pavementpreservation.org. Additional support provided by Michigan State University.